In 2011, NASA's Kepler Space Telescope confirmed a landmark discovery: the first planet found squarely within the habitable zone of a sun-like star. The announcement sent a jolt of pure, unadulterated excitement through the world. Located about 640 light-years away, Kepler-22b was immediately hailed as a potential Earth 2.0. It became a media sensation, a symbol of hope. Artists' impressions, commissioned and spread widely across every news outlet and social media platform, showed a mesmerizing world of deep blues and brilliant whites, a marvel of cosmic artistry that looked profoundly alive and incredibly welcoming. It was more than a scientific finding. It represented a promised land, a tangible destination in our species' long and often lonely search for a new home among the stars. The image of a vibrant, living world, a second Eden waiting for us across the cosmos, was seared into the public consciousness. But the promise of a new Earth is often built on a fragile foundation of hopeful assumptions. The term habitable zone simply defines an orbital region where conditions might be right for liquid water to exist on a planet's surface. It's a celestial address, not a guarantee of paradise. It doesn't account for a dozen other factors that make a world truly livable. The closer we look at the brutal physics of a world like Kepler-22b, peeling back the layers of artistic fantasy and confronting the scientific probabilities, the more a daunting question emerges. What if this so-called second Earth is not a welcoming oasis, but a cosmic tomb, exquisitely designed by the indifferent laws of the universe? Imagine an unprotected human somehow arriving after an impossible journey across 640 light-years of empty space. That monumental trip would culminate in a horrifyingly swift end, an existence that lasts less than 10 seconds. To understand why, we must perform a kind of hypothetical autopsy, dissecting each of the forces and environmental horrors that would conspire to cause this swift, catastrophic, and total systemic failure. The very moment you materialize, you experience a fundamental betrayal by the laws of physics you've always taken for granted. While its radius is known to be about 2.1 times that of Earth, Kepler-22b's mass remains one of its greatest mysteries. As of 2023, scientific models place an upper limit on its mass at around 9.1 times that of our planet. If Kepler-22b is a dense, rocky world near this upper limit, its surface gravity could be more than double what we experience on Earth. This isn't just a feeling of being heavy. It's an acute, systemic, biological crisis. Your heart, which has evolved over millions of years to pump blood against the familiar pull of 1G, would be forced to labor against an insurmountable load. It would strain violently, unable to generate enough pressure to push an adequate supply of oxygenated blood up to your brain. Your legs, accustomed to supporting your body weight, would buckle instantly. Their bones and muscles never meant to bear such a crushing force. The simple act of standing becomes an impossible feat of strength. Your spine compresses violently, and the 15 kilograms of your head and neck suddenly feel like 30, an unbearable strain that could snap vertebrae. You wouldn't just fall. You would be slammed into the ground by a force your body cannot comprehend, your skeleton shattering like glass under the unyielding load as you lie paralyzed and broken on the alien ground. Your body's autonomic reflexes would scream for one thing: oxygen. But the air you would desperately gasp is not life, but a swift and silent death sentence. The leading hypothesis for a planet of this size is that it is not a rocky super-Earth, but a mini Neptune, a body with a thick primordial atmosphere composed mainly of hydrogen and helium. These gases are simple asphyxiants. They contain none of the oxygen your mitochondria need to produce energy, and with each desperate, reflexive breath would displace every last molecule of it from your lungs. The sensation is not like holding your breath, which triggers alarms in your brain due to the buildup of carbon dioxide. Here, you are actively flushing the life-giving oxygen out of your system, leading to a silent, terrifyingly rapid onset of profound hypoxia. Within seconds, your brain, starved of oxygen, would begin to shut down, initiating a cascade of failures that would render you unconscious. But the problem could be even worse. The atmosphere might be laced with toxic compounds like ammonia or hydrogen sulfide. These don't just suffocate, but actively poison your system, chemically burning your sensitive lung tissue on contact, turning your final breaths into an act of self-destruction. As your vision tunnels from oxygen deprivation, a new and even more violent horror announces itself. It's not just the composition of the atmosphere, but its sheer weight. A thick atmosphere, as hypothesized for a mini Neptune, could exert a surface pressure dozens or even hundreds of times greater than Earth's. The sensation would be one of being squeezed from all directions at once, an experience similar to being instantly teleported a kilometer beneath the ocean. This is catastrophic barotrauma. The air-filled spaces in your body, your sinuses, your eustachian tubes, your middle ears, would implode instantly, shredding delicate tissues and rupturing your eardrums in a flash of white-hot pain. But the most devastating impact is on your lungs. Already filled with unbreathable gas, they would be subjected to a crushing external force. This would trigger a fatal event known as a pulmonary barotrauma. The immense pressure would rupture your alveoli, the tiny air sacs in your lungs, forcing the alien gases from your lungs directly into your bloodstream and creating an arterial gas embolism. Bubbles of hydrogen and helium would travel like torpedoes through your arteries to your brain and heart, causing massive, simultaneous strokes and a near-instantaneous cardiac arrest. This isn't drowning. It's a complete, violent collapse of your circulatory system from the inside out. In the last fleeting moments of consciousness, a final triad of environmental factors comes into play, each one a death sentence in its own right. The first is temperature. Kepler-22b sits in the habitable zone, where, with an Earth-like atmosphere, surface temperatures could be a pleasant 22 degrees Celsius, 72 degrees Fahrenheit. but a thick, dense atmosphere, rich in greenhouse gases, would inevitably trigger a runaway effect, similar to what happened on Venus, turning the planet into a 460 degrees Celsius, 860 degrees Fahrenheit hellscape. In this scenario, your body would be flash-cooked in seconds. Alternatively, if the planet has little to no atmosphere, it would lack the thermal blanket needed to retain and distribute heat. Temperatures would swing wildly between scorching days hot enough to melt lead and frigid nights cold enough to freeze nitrogen solid. You would either be incinerated or flash frozen. And then there is the radiation. On Earth, we are protected by a global magnetic field, an invisible shield that deflects deadly cosmic rays and unfiltered stellar radiation from our sun. We have no idea if Kepler-22b has one. Without it, the surface is continuously bombarded by high-energy particles from its star and deep space. This radiation would shred your DNA and cause severe, full-body radiation burns, effectively cooking you on a molecular level. Your 10 seconds are up. The promise of a new Earth has revealed itself to be a multi-layered, inescapable death trap. The artist's impressions are almost always the same: a world of deep, endless, inviting blue. Indeed, the most popular and scientifically plausible model for Kepler-22b is not a rocky super-Earth, but a water world, a planet completely covered by a single, globe-spanning ocean. Its size and position in the habitable zone make it a prime candidate for hosting vast quantities of liquid water. But plunging into the seas of Kepler-22b would just be a different, and perhaps more terrifying, way to die. Imagine your craft splashes down in this global ocean. The water you would encounter would likely be nothing like Earth's life-sustaining seas. Our oceans are salty because rivers constantly run over continents, eroding rocks, dissolving minerals, and carrying them to the sea. This process buffers the ocean's chemistry. On a world with no land, what would be dissolved in its water? Without the geological and chemical stabilizers of continents, the ocean could become highly acidic from billions of years of dissolved volcanic gases like carbon dioxide and sulfur dioxide, creating a bath of corrosive acid. Or it could be intensely alkaline, a caustic, soapy brine capable of dissolving organic tissue. Worse, it could be saturated with a cocktail of toxic compounds and heavy metals, leached directly from the planet's mantle into the ocean floor over eons. A single drop touching your skin could mean a painful death by chemical burn or acute heavy metal poisoning. Even if the water were miraculously pure, you would face the crushing physics of the deep. On a planet with potentially double Earth's gravity, the water pressure would increase at a terrifying rate as you descend. The sheer weight of the water column above would be immense. As you descend further, the water itself would begin to change. Under the immense pressure from hundreds or thousands of kilometers of ocean, water is forced into exotic, high-pressure phases. It would no longer be the familiar liquid we know, but would compress into dense, crystalline forms like Ice 7 or Ice X, which can remain solid even at blistering hot temperatures. You could find yourself crushed against a seafloor made of hot, black ice. Before reaching that bizarre layer, you might encounter another state of matter entirely, a supercritical fluid. This happens when a substance is at a temperature and pressure above its critical point, where distinct liquid and gas phases cease to exist. To be immersed in supercritical water would be a uniquely lethal experience. It possesses the density of a liquid, but can diffuse through solids like a gas, and it acts as a powerful non-polar solvent, dissolving organic compounds with frightening efficiency. Your body would be simultaneously crushed by the immense pressure, permeated by a substance that moves like a gas, and chemically dissolved on a molecular level. The ocean of Kepler-22b is not a cradle for life as we know it. It is a planetary-scale laboratory for extreme physics, where the laws of nature conspire against biology. The sheer scale of the technology required to survive on Kepler-22b, even for a moment, forces us to confront a series of profound questions. The quest to conquer such a world is not just a monumental engineering problem. It's a philosophical one that challenges our most basic assumptions about life and our place in the cosmos. Kepler-22b's greatest lesson is a sobering one. The habitable zone is a misleadingly simple concept. The term, defined as the orbital region where a planet could support liquid water, has been seized by the public imagination as a synonym for Earth-like. But habitability is a complex dashboard of countless interconnected variables. It includes gravity, atmospheric pressure and composition, the presence of a protective magnetic field, planetary mass and density, the planet's axial tilt, which governs seasons, the stability of its orbit, and the type and volatility of the host star. Kepler-22b teaches us that finding a true second Earth is infinitely harder than just finding a planet at the right address. We are looking for a world that is just right in a dozen or more different ways, a confluence of conditions, so specific and so interdependent that its occurrence may be extraordinarily rare. If a human cannot survive for 10 seconds on its surface, does that mean Kepler-22b is lifeless? Absolutely not. It simply means it is lifeless for us. The very same conditions that make it an instantaneous death trap for an oxygen-breathing, carbon-based organism from a 1G world could be the perfect cradle for something else entirely. Life could thrive on chemical energy from hydrothermal vents in the crushing depths of its global ocean, a process known as chemosynthesis. It might be microbial, perhaps vast ecosystems of bacteria or archaea that metabolize sulfur or methane instead of sunlight and oxygen. Over billions of years, it could have evolved into complex organisms with a biochemistry we can't even imagine, perfectly adapted to the crushing pressure, toxic chemistry, and bizarre physics of their home. Perhaps life there is silicon-based, with bodies structured like living rock. The ultimate question is not whether a planet is habitable, but habitable for whom? Ultimately, the study of a hostile world like Kepler-22b holds up a mirror to our own. For all its challenges, political strife, and natural disasters, Earth is a paradise of seemingly impossible perfection. We exist in a gravitational field, gentle enough to allow a child to stand and run, yet strong enough to hold onto a precious, protective atmosphere. We breathe an atmosphere rich in the oxygen that energizes us, yet thin enough not to crush us, and dense enough to shield us from the worst of the sun's radiation. We are protected by an invisible magnetic field that silently wards off deadly cosmic radiation from deep space. Every single horror we imagine on Kepler-22b is a danger we do not have to face. Here, a theoretical journey of 640 light-years to a hellish alien world ends with a profound and humbling return to a fundamental truth. There is, for now, and perhaps forever, no place like home. Kepler-22b was born in a flurry of collective hope, its discovery painting a tantalizing picture of a sister world waiting just for us. But the reality, governed by the cold, hard, and unforgiving laws of physics, is far more complex and terrifying. This so-called second Earth is a world of violent possibilities, any one of which would be instantly fatal to a human being. To conquer it would require technology that is, for us, indistinguishable from magic. Fully self-contained habitats, artificial gravity manipulation, and planetary-scale atmospheric processors, forever confining us to artificial bubbles, eternal aliens, on a world that may already be teeming with its own strange and wonderful version of life. Perhaps one day our distant descendants will develop the means to make that incredible journey and witness its wonders firsthand from the safety of their ships. But for now, Kepler-22b serves as a vital, humbling lesson. It reminds us that the universe was not designed for us, and that the gift of a truly habitable world, our Earth, with its gentle gravity, breathable air, and protective magnetic shield, is more precious, more fragile, and perhaps more unique than we can possibly imagine.